Hello and welcome to video VHDL Concept 2. We're going to be studying how to do combinational logic in VHDL and also how to write a test bench. So what I'm constructing right now is a simple combinational circuit. We have one AND gate, one XOR gate, and there's one NAND gate. There are four inputs to this circuit. We have A, B, C, and D, which we'll mark shortly. Now this is from a circuit simulator called Logisim, if you're interested in it. It's a free logic circuit simulator. Anyway, that circuit works. So the first thing we're going to do is declare our entity in VHDL. Notice the library IEEE, and we're also using standard logic 1164.all. That is at the top. So we describe our entity, give it a name. We have our port declaration. A, B, C, and D are the inputs of type standard logic. C is an output of standard logic. So we're going to put some intermediate signals in our hardware. You don't have to do this. We have signal AND out. This is the output of the AND gate of A and B, and we have an XOR out from the output of the XOR of C and D, and they're also both standard logic signals. So we simply use an AND declaration. It doesn't get simpler than that. A and B tells us that AND out is going to be an AND output of A and B, and XOR out is going to be an XOR output of C and D, using those keywords AND and XOR. The NAND keyword gives us the NAND between those successive signals. And this is pretty much how you can describe the circuit. Now using Xilinx Vivado 2015.2, we can go to the schematic view of this circuit and see what it conjures up. So it pretty much gives us the circuit we have been wanting to describe. So our tool chain knows what we're trying to do. What I'm going to do now is add a test bench. We want to add a test bench to simulate the circuit. This example is pretty trivial, but when you have a much larger circuit, you will certainly want to simulate it and see how it behaves. In this video, we're just simply covering how to write a test bench. And a trivial example really helps illustrate it without getting lost in details that are just unnecessary. So just for the purpose of this video, we're going to write a test bench for this circuit. Now the test bench does not have any ports, pretty much follows the same format as any other entity, except there are no ports. So remember that. Test bench has no ports. Next, we're describing our test bench signals. Now, I usually write A underscore T, B underscore T, so on and so forth, dash or underscore T. I use an underscore T for test bench signals. You don't have to do that. You can name them whatever you want, whatever's easier for you. Notice the two colons back to back on the line signal Z underscore T, standard logic in our test bench signals. This is a syntax error. It's very bad. In fact, it's insidious and sometimes hard to find. You'll get a message like this, which says you don't have read, write, or execute permissions. So it does help sometimes to look in the Tickle console. It will give you a clue as to what might be wrong. So we have an error around lines 12, possibly 25. Anyway, just be aware of this. Next, we have to import our component. This is our component. We have to copy our port map into the component description. And notice this is between architecture and begin. So we're not writing any of this after the begin statement. Next, we designate our unit under test using the syntax with a port map. Now I'm mapping the test signals I've designated in the test bench signals in the port map. Now we have a process. This is our test bench process. Just follow the format. And from here, we can assign our signals values. So I have a wait for statement. Wait just tells the simulator to wait for 10 nanoseconds, and then we're assigning all of these test bench signals, these values, at the exact same time in the simulation. Then I'm going to wait again, waiting for another 10 nanoseconds, and then another assignment of all these signals at the same time. I'm not assigning z of t any value because that is an output signal that's driven by something. It's driven by our combinational logic circuit, so there's no reason to assign that anything. It will be assigned by the simulator as it runs through the simulation process. I put a wait for 500 nanoseconds. This will show a space in our waveform simulation, as you'll see shortly. We can have any number of processes. It gets complicated if there are signals that are used in different processes. They will have a tendency to overwrite each other, and things get very confusing at that point. The simulator will run this process repeatedly, over and over and over, for the entire length of the simulation, or however long you decide to simulate it. You can have multiple test modules if you like. It's usually a really good idea to have one unit under test in one test bench, or wrap up all your submodules in a single unit. Now there's an error in this test bench, and the error happens to be, well, it happened to be where there was a colon. That was fixed. I had put a colon after z of t in the test bench port declaration. Anyway, that's been fixed. What we have here is our test bench waveform. We have to put all our test bench signals that we want to observe into the window on the right-hand side, and then rerun the simulation. Initially, there's no signal assignments because there was a wait for statement for 10 nanoseconds. So nothing was assigned. The signals were undefined. We start running it a little bit more, and we start getting results through the test bench. This is our 500 nanosecond wait period, in which there's really no activity. And the test bench wraps around right about now. There we go. It will continue to do that. We can run this simulation indefinitely if we wanted to, but we're not going to do that here. So this is fundamentally how to describe combinational logic and write a test bench in VHDL. Follow the syntax in the video. Play around with it, certainly. Make up your own combinational logic circuit and see what you get. To do that, you need to know some of the other syntax. These are other logic gates we can describe in VHDL. We have a NOT gate, AND gate, OR gate, NAND, NOR, XOR, and an XNOR. These all come from our IEEE library. Standard logic 1164. From that statement in our library declarations, we using IEEE standard logic 1164.all. So again, this all comes from that standard logic 1164 library. If you did not include this in your code, then you wouldn't be able to use these logic gates. And to use them, we can simply use the keywords, which are appropriately named as the gates they describe: NOT, AND, OR, NAND, NOR, XOR, and XNOR. And these are the signal assignments you would use, assuming your output was Z and your inputs were A and B, right? We'll get into this in more detail, and I will probably include some practice problems in future videos to describe combinational logic. Anyway, thanks for watching. In the next video, we are going to explore sequential logic, combinational logic, and the process blocks. And that will allow you to use things such as registers and describe a lot more functionality in VHDL. Anyway, I hope to see you there.